If x is real, the minimum value of a plus x into b plus x divided by c plus x for x strictly greater than negative c. This is very important. A greater than c, b greater than c is square root of a minus c plus square root of b minus c whole square. We need to show that minimum value of this is this, right? Okay. So let's consider this expression to be equal to y. And on simplifying this, we get a quadratic equation in x. So this is ab plus ax plus bx plus x square is equal to yc plus yx, and then x square plus the coefficient of x, that is a plus b minus y, plus ab minus cy is equal to 0. So this is the quadratic equation in x. Now it is given to us that x is real. If x is real, what is the result for x to be real? If x is real, the discriminant should be greater than equal to 0. Right? So let's find the discriminant for this equation. So that is the square of the coefficient of x minus 4 times the coefficient of x square into the constant, that is ab minus cy. So this should be greater than equal to 0 for x to be real. So when we open this bracket, this becomes a plus b whole square plus y square minus twice of a plus b into y minus 4ab plus 4cy greater than equal to 0. Simplifying further, we get this to be as y square minus, writing the coefficient of y, a plus b minus 2c, and then plus a plus b whole square, that is a square plus b square plus twice of ab, and this is minus 4ab. So this becomes minus twice of ab. So this is your formula, that is a minus b whole square. So this is a minus b whole square greater than equal to 0. So we are getting the quadratic inequality in y, right? Now this is possible if y does not lie between the roots of the equation y square minus twice of a plus b minus 2c into y plus a minus b whole square equal to 0. So this is possible if y does not lie between the roots of the quadratic equation in y, right? So let's get the roots of this equation. So y is equal to negative of coefficient of y, that is twice of a plus b minus 2c, plus minus square of this minus 4 times a minus b whole square divided by 2. So this is equal to twice of a plus b minus 2c, plus minus taking square root of 4 outside, we get 2, and inside we are having this first bracket square plus second bracket square. So we can apply the formula for x square minus y square, that is x minus y into x plus y. So first bracket plus second bracket, that gives 2a minus 2c, and first bracket minus the second bracket, that gives 2b minus 2c divided by 2. So cancelling 2 from the numerator and the denominator, we get a plus b minus 2c plus minus, if I take 2 common from this bracket and this bracket, then we get 4 outside from these brackets, and square root of 4 is again 2. So this is square root of a minus c into b minus c. Then we can write this first bracket as, a minus c plus b minus c, so that we can get the formula. So let's write a minus c as square root of a minus c whole square plus square root of b minus c whole square plus minus twice of square root of a minus c into square root of b minus c. If this is your complete a and this is your complete b, then this is a plus b whole square or a minus b whole square, right? So we get y to be equal to square root of a minus c plus minus square root of b minus c whole square. Now we know that this y should not lie between these roots, right? Either y is greater than equal to square root of a minus c plus square root of b minus c whole square, or it is less than equal to square root of a minus c minus square root of b minus c whole square. Let's check which of these is correct. Let's consider the second one first. Suppose y is less than equal to square root of a minus c minus square root of b minus c whole square, right? And we have considered y to be equal to product of a plus x, b plus x divided by c plus x. So let's put this value. So it is a plus x into b plus x divided by c plus x less than equal to square root of a minus c minus square root of b minus c whole square. So this implies, let's open the numerator, we get x square plus a plus bx plus ab less than equal to c plus x into, opening this bracket, it is a minus c plus b minus c minus twice of square root of a minus c into square root of b minus c. Negative c and negative c becomes minus twice of c. So this is a plus b minus 2c. Taking this complete right hand side to the left hand side so that I can get a quadratic inequality in x. So we get x square plus a plus b into x plus ab and minus of a plus b minus 2c minus twice of square root of a minus c into b minus c, and c plus x is also multiplied with this less than equal to 0. So this implies x square plus, writing the coefficient of x, that is a plus b minus a minus b plus twice of c plus twice of square root of a minus c into b minus c. This x is multiplied with this complete bracket, and then the remaining constants plus ab minus ac minus bc plus 2c square plus 2c square root of a minus c into b minus c less than equal to 0. Please remember one thing. When we have taken this complete right hand side to the left hand side, this inequality does not change because c plus x is positive. It is given to us. X is greater than negative c. That is, x plus c is positive, right? So that is why when we take this right hand side to the left hand side, this inequality, the sign remains the same. This a cancelled out, this b cancelled out, and we get x square plus, taking 2 outside, twice of c plus square root of a minus c into b minus c into x plus, if I consider these 4 terms first, that is ab minus ac minus bc plus 2c square. Can I write 2c square as c square plus c square? From these two, if I take a common, I get a into b minus c. And from here, if I take negative c common, I get b minus c plus c square. So from here, I get a minus c into b minus c plus c square. So writing this, so this is plus a minus c into b minus c plus c square plus twice of c into square root of a minus c into b minus c less than equal to 0. Yes? Okay. So this is x square plus twice of c plus square root of a minus c into b minus c x plus I can write a minus c as square root of a minus c whole square into square root of b minus c whole square plus c square plus twice of c square root of a minus c into b minus c less than equal to 0. This is your formula, that is a minus c into b minus c plus c whole square, right? So writing this, x square plus twice of c plus square root of a minus c into b minus c plus c plus square root of a minus c into square root of b minus c whole square less than equal to 0, right? Sorry. Now again, this is your complete formula, that is x plus c plus square root of a minus c into square root of b minus c whole square. Can you get this? Yes. So this is less than equal to 0. Now this can be possible if your x is equal to negative c negative of square root of a minus c into b minus c. Then only this can be possible. But let's rethink, is this valid or not? As it is given to us that x is strictly greater than negative c. So if x is strictly greater than negative c, how can x be equal to negative c negative of square root of a minus c into b minus c? It cannot be possible. So this contradicts our assumption that x is greater than negative c, right? That means this option is not valid. That is, this option is not valid, which means this is the valid option. So y is greater than equal to square root of a minus c plus square root of b minus c whole square, right? That means this right hand side is the minimum value of y. So hence the minimum value of y is square root of a minus c plus square root of b minus c whole square. Alright, thank you. Stay blessed.